Uh, Good morning, students. So today we will discuss about the operation of the Jfet. Okay. So for working of the Jfet, we have to apply the voltages. Okay. So application of voltage it is called as the biasing. So we are discuss about how the Jfet works. Okay. So for example, this is the diagram of N channel Jfet. So as you see the construction. Uh, for N-channel JFET, we have taken one silicon bar of N-type semiconductor, and at the either side we have diffused the two P-type semiconductor. Okay, and this P-type semiconductor they are internally connected together, and common terminal called as gate derived from this P-type semiconductor. From this N-type silicon bar, we have taken out two terminal called as source and drain. So JFET has essentially a three terminals: source, drain, and gate. Okay. So this is the symbol of N channel JFET. So now for working for its operation, we have to apply the voltage to the JFET. Okay. So now this is the circuit diagram of the JFET. So we have applied the voltage between drain and source. Okay. So drain we have connected the positive of the battery, and negative it is connected to the source terminal. Okay. This voltage it is called as the VDS. So VDS voltage हमने apply किया है between the drain and source. Now for the operation what we have done, we have applying the reverse bias VGS between gate and source. So we have applied the reverse bias VGS between gate and source. So how to apply the reverse bias voltage? For example, N channel JFET gate is made up of P-type semiconductor. So gate terminal it is made up of P-type semiconductor. So we apply the negative of battery to this gate terminal, and positive is connected to the source terminal. So we have applied the negative VGS to the between gate and source. Now what happened due to this negative VGS, when we are applying, suppose initially the VGS is 0, we have not applied any VGS, but we have applied the VDS. We have applied the VDS. Okay, so due to this PN junction, depletion region will form, and as we have applied the VDS, the electrons start flowing from source to drain, and the current ID start flowing from drain to source. Okay, so at this time the VGS value is 0. We have applied only the VDS. So if you see on the graph, when we have there is the 0 VGS and we have applied the VDS, the current ID is maximum and it is represented as IDSS. Okay, so the current is maximum at that time and its value is equals to IDSS. Okay, so it's a maximum current flowing through the JFET when we have not applied any VGS. Okay, now what happened? Suppose we have applied the VGS. We have suppose applied the VGS equals to 1 ohm. So then what happened? As the VGS, it is the reverse bias. This depletion region, it is grow. Okay, it is increases, and because of that, the width of this conducting channel is goes on decreasing. आप अगर compare करोगे जब VGS 0 था, तो width is more. Now width of conducting channel is more, it's maximum. And when we apply increase the negative VGS, what happened? As the depletion region increases, the width of conducting channel is reduces, and so small number of electrons start flowing from source to drain, and therefore the current value ID it is start decreasing. So as you goes on the increasing the VGS, this depletion region it is goes on increasing, and width of conducting channel it goes on decreasing, and because of that the current is also start decreasing, and at some value of VGS both the depletion region touches to each other. Okay, now both the depletion region touches to each other and there is now no conducting channel present between source and drain, so no electron able to flow from source to drain. So value of ID becomes 0. So current conduction stop. So the value of VGS at which ID becomes 0, it is called as cutoff voltage. So value of VGS at which the current conduction stop, it is called as the VGS cutoff voltage. So it is indicated from this graph. So when VGS is 0, that time your ID is maximum equals to IDSS. And as we are increasing the negative VGS, the ID goes on decreasing. And at some value of the VGS, ID becomes 0. And that value of VGS is called as VGS cutoff voltage. So this is the transfer characteristics of N-channel Jfet. Okay, so this is about the operation of the N-channel Jfet. So here we have discussed the operation of N-channel Jfet. So we will stop here.